Welcome. This is the lesson everyone or everything has been building towards polymorphism. It's a fancy word for a beautiful idea that the same method call can do different things depending on the actual object. This is a centerpiece of the AP Computer Science A course and exam, so we'll take it step by step until it feels really natural for you guys. Let's dive right in. Alright, lesson objectives. You'll define polymorphism in your own words, explain how method overriding sets it up, describe dynamic dispatch and how Java picks which version to run at runtime, and write code that loops over a mixed collection of objects, calling one method on all of them. Master these, and you've mastered one of the most heavily tested ideas. I keep saying it, and I'm going to say it again, so please get this going. Alright. Polymorphism literally means many forms, and that's exactly what it gives us. The same method call can produce different behaviors depending on which actual object receives it. You write speak once, but a dog barks, a cat meows, and a cow moos. One call, many forms. The crucial thing to understand is that the decision about which version runs is made at runtime based on the actual object, not at the compile time based on the declared type. That's what makes polymorphism feel kind of magical, actually. Your code stays general and simple while the objects supply the specific behavior. Over the next few slides, we'll see the two ingredients that make this work: method overriding and dynamic dispatch. Alright, polymorphism doesn't happen by itself. It's built on method overriding. Overriding is when a subclass provides its own version of a method that the parent already declared, using the exact same signature, the same name, and parameters. In the example, animal defines speak and dog overrides it to bark while cat overrides it to meow. We mark these with the @override annotation, which is optional but smart because it tells the compiler to verify you really are overriding something and catches typos. Without overriding, every object would just run the parent's version and there'd be no variety. So overriding is the foundation. It's what gives each subclass its own distinct behavior for a shared method name. Alright, the engine under the hood. It's the most important concept in the lesson. It's called dynamic dispatch, or late binding. When you call a method on a reference, Java waits until the runtime and looks at the actual object to decide which overridden version to execute. It does not use the declared type for this decision, so an animal variable holding a dog will run dog speak every time. Contrast this with the previous lesson. The declared type decided which method you could call, but the actual type decides which version actually runs. Those are two different questions answered by two different types. Method selection happens late at runtime based on the real object. That single sentence is the heart of polymorphism. Now let's put it all together and see the payoff in real code. We make an array of the parent type, fill it with different subclass objects, and loop through calling the same method on each. Thanks to dynamic dispatch, each object automatically runs its own overridden version. So the dog barks and the cat meows from the exact same line of code. Notice what we did not have to write. No if-else chain checking what type each object is. The objects sort that out themselves. And here's the real beauty. If you add a new subclass next year, this loop still works on it with zero changes. Write once, extend forever. That's the elegance. Alright, what is printed? Trace the output of this loop. Pause the video and answer the question. First element is an actual A object. A.m returns A. Second element is an actual B object. B overrides M, so dynamic dispatch runs B.m returning B, even though X is declared type A. Concatenated output is AB. The answer, B. Declared type A made the call legal. The actual object type chose which M method ran each time. Alright, try this. Reasoning check. Shape declares get area. Circle overrides it. Square does not. Which statement is true? Pause the video and try. Option A is false. A square is a shape and it fits the shape array. Option C is false. Polymorphism means circles override runs based on the actual object, regardless of the reference being shape or circle. Option D is false. A subclass inherits the parent's method and does not need to redeclare it. Option B is true. Square didn't override getArea, so it simply inherits and uses shape's version. Answer B. Overriding is optional per subclass. Whichever version is closest in the object's own hierarchy is the one dispatched. Alright, key takeaways before we sign off. Polymorphism means one method call can produce many behaviors. It builds on overriding, where subclasses redefine the parent method. Dynamic dispatch means Java chooses the version to run at runtime based on the actual object, not the declared type. And the payoff is general code that works on every current and future subclass without changes. This is the cornerstone of the exam, so make sure it clicks before moving on. Excellent work, guys.